Hey guys, welcome back to my channel. In the previous video, we finished till question number 10, sub-question number 10 of main question number 3 in exercise 13A of OP Malhotra textbook for ISC Mathematics. Today we'll be doing the rest of the two questions and then we'll move on to question number 4 and 5. So let's begin. Okay guys, so the 11th question is integral of sec x upon sec x plus tan x. So basically, whenever I see sec x and tan x, I might as well convert it into sine and cos. So let's simplify it. 1 by cos x upon 1 by cos x plus sine x by cos x. Because keeping it in this form, it's not going to get you anywhere, right? So might as well simplify it and see if something comes up. So then 1 by cos x upon 1 plus sine x by cos x. So now you can see that we can take the reciprocal of this and that will turn into multiplication. So cos x 1 plus sine x dx, and this will get cut. So now we're left with 1 upon 1 plus sine x. Now normally if you have 1 upon 1 plus sine x, you can just multiply and divide by the conjugate of this. So what we'll do is 1 plus sine x into 1 minus sine x, 1 minus sine x. So multiply the numerator and the denominator by 1 minus sine x. So this will take you to 1 minus sine x, and a plus b, a minus b is a square minus b square. So this will become 1 minus sine square x, which is ultimately cos square x. Now this can be written as in two different terms, 1 by cos square x minus sine x by cos square x. 1 by cos square x as sec square x minus, so sine by cos becomes tan, and one extra cos down there will become sec. And we know how to integrate these two terms easily, because the differentiation of tan x is sec square x and the differentiation of sec x is sec x tan x. So the final answer becomes tan x minus sec x plus c. That's the constant, and when we differentiate this entire thing, this becomes 0. So this is the final answer. So let's move on to the 12th question now. The 12th question is integral of 3 cosec square x plus 2 sine of 3x. Okay, this is relatively simple. So we can leave the constants outside. We can integrate these two separately. 3 integral of cosec square x plus 2 integral of sine 3x. Now we know that the integral of cosec square x is minus cot x, because when we differentiate minus cot x, we are left with minus of minus cosec square x. So ultimately that becomes cosec square x. So this should be minus 3 cot x plus 2. So integral of sine is minus cos. So minus cos 3x, and the coefficient of x, which is 3, goes in the denominator, plus c. So the final answer is minus 3 cot x minus 2 by 3 cos 3x plus c. With that, we finish the question number 3, and now we move on to question number 4. First sub-question of question number 4 is integral of cos 4x cos 3x dx. And if you turn to page number 13.7 in your book of OP Malhotra, you can see that we integrate cos x cos y like this. We can write it like this: half cos x plus y plus cos x minus y. So let's write it like that. Half, and into brackets, cos 4x plus 3x plus cos 4x minus 3x. So this half can stay outside as a constant. This will become cos 7x, and this will become cos x. So the final answer, we know that the integral of cos is sine. So the final answer will become sine 7x upon 7, of course, plus sine x plus c. So let's take the final answer simplified term, 7x upon 14 plus sine x by 2 plus c. Guys, let's move on to the second sub-question of question number 4, which is integration of sine 4x sine 8x. Again, if you turn to page 13.7 in your textbook, you will find that the way to write sine x sine y in a simpler term is half cos x minus y minus cos x plus y. So let's just go ahead and write it like that. Half into brackets cos x minus y, so cos 4x minus 8x minus cos x plus y, so 4x plus 8x. Now we know that this will become minus 4, but of course when we have a minus angle in cos, that automatically turns into a positive angle. That's the standard rule. So the angle would be cos 4x again. It won't be minus 4x because it's a cos angle. Minus cos 12x. So let's just go ahead and write that in the integral sign. So half goes outside, cos 4x minus cos 12x dx. So the final answer would be half sine 4x by 4 minus sine 12x by 12 plus c. And in the final answer, when we multiply this with half, the final answer will become sine 4x by 8 minus sine 12x by 24 plus c. Okay guys, so let's do two more questions, the two sub-questions of question number 5. So the fifth question, number 1, is integration of cos 2x, cos 4x, and cos 6x. Question number 2, the sub-question number 2 of question number 5 is actually quite similar. So I'll just do number 1 and you can figure out number 2 with the process of number 1. Okay, so what we are going to do is similar to what we did in the previous question. So we know that cos x, cos y, we can write it in terms of half cos x plus y plus cos x minus y. So what we're going to do is these first two angles, we'll write it like that. Half cos x plus y would be 6x, and then we have to do plus cos x minus y, so that will be 2 minus 6, which is minus 4. I'm so sorry, this angle. So 2 minus 4, which is minus 2, but because it's cos, it will turn into a positive 2. The whole thing, sorry for the brackets, I'm using the wrong brackets, dx. Okay, so now let's go ahead and simplify. So this becomes cos 6x by 2 cos square, because you have to multiply that this angle 2, plus half of cos 2x cos 6x. Okay, now you can take this as two different terms. Half goes outside and this can be written as only cos square 6x, plus again half goes outside, and then cos 2x cos 6x, we can again write it in terms of half cos x plus y plus cos x minus y. So that will become half cos 8x plus cos 4x. Now we know that we write cos square as 1 minus cos of double angle by 2. So that will become 1 by 2 integration of 1 plus cos 12x double angle of this upon 2 dx. Plus we can take half outside, so that becomes 1 by 4 integration of cos 8x plus cos 4x. So now we can write this as integration of 1 by 4 outside, integration of 1 plus cos 12x plus 1 by 4 cos 8x plus cos 4x dx. So 1 becomes x plus cos goes to sine 12x by 12 plus 1 by 4 sine 8x by 8 plus sine 4x by 4. So you can just open the brackets and multiply with these constants and you'll get the final answer. And don't forget the plus c. So that's it for today, guys. I'll see you in the next video and we'll continue with the sub-questions of question number 5. Thank you so much for watching. Bye, guys.